Hello, this is Ian Walker, and today I will be showing you how I did my state machine project. So here is a state transition diagram. So it starts with the lights on, then they go off, at which point the motors switch off. Then when the lights turn back on, it starts a timer, it waits 5 seconds, it initiates your forward command. If it detects an object, it goes into its reverse commands, wait 1 second, then goes back to the forward command. And it will constantly do this until the time expires, at which point it would switch to its manual mode. This diagram is also written as if it were to be put into a robot and not use the LEDs like were used in this project. This is a basic interpretation of the circuit diagram. Digital pin 3 was used, analog pin 3 was used for the IR sensor and the light sensor respectively. The IR sensor is technically an analog sensor, but it functions just as well as a digital sensor. Pins 7, 8, and 9 are all three, output sensors that have a 500 ohm resistor with the LEDs appropriately all grounded. This was an earlier setup that I put on here, that this more or less was not a state machine, that it more or less was standard code with event checkers, and that it would call different functions as it went along. As you can see here, this is not a state machine, and these are the functions I would call, which they somewhat hold a state, but not really. So this is how my actual code went. Here you can see my switch pin and read pin. Those are both the input pins. Threshold value of 50. I had played with this a little bit. That this threshold value this threshold value was originally 30, but I upped it to 50 as 30 was a bit too sensitive. Here next you see state, time 2, or time 1, time 2, T, and D. State is just the state that the machine is in. Time 1 is when it enters state 2. Time 2 starts recording when it enters state 3. T is the difference between those two, and D is the time that it takes in autonomous mode, or the time that it's spent in autonomous mode. In the void setup, you can see this again, that the pin modes for each of the different pins mentioned before. These are the analog, this is the analog event checker. Not much to see here, but it is important to note this piece of the code. Similarly with the digital event, they're very simple pieces of code, but very important. Now onto the states. In state 0, it's waiting to see if an event occurs, at which point the lights would be on. It checks to see them to switch on, turns on, or leaves your LED alone, and switches to state 1. State 1 then waits to see if the lights are off, and then it will stay in that state until state 2, when the lights turn back on, and it starts a timer. At which point it starts recording time 1 and a delay of 5 seconds in order to, for this project and specifically, it would be for lifting the box off of the robot and ensuring everything is out of the way. That 5-second delay is for that. I forgot to mention, in state 1, the motor LED would turn on, signaling that the motors are off. Yes, that is inversely correlated. At which this point, once it starts a timer, the motors are on, so they are off. Now we enter state 3. State 3 is your main forward command. Time 2 starts recording now. T, as you can see, is the difference between those, as well as the time so far that it has been in autonomous mode, and D is the time allowed in autonomous mode. When the timer is at a lesser state than D, This is when it can detect if there's a collision or not, and it also turns on the autonomous mode LED. If it detects a collision, it goes to state 4, and when the timer runs out, it moves to state 5. And here are states 4 and 5. 4, it turns on the LED and waits 1 millisecond to make sure everything works properly, and then returns to state 3. When in state 5, it would shut off the autonomous mode LED, signaling that it is in manual mode. Thank you for listening to my presentation.